Assalamualaikum warahmatullahi wabarakatuh, and good morning to my panel, Dr. Muhammad Faid and Dr. Muhammad Zulkifli. My name is Muhammad Saifullah Berusalmi and my supervisor is Dr. Muhammad Khairi bin Muhammad Nur. Today, I would like to present my FYP project, which is development of underwater cleaning machine. First is an introduction. Underwater cleaning machine for this project is a robotic pool cleaner. Robotic pool cleaners can gather unwanted particles from the pool floor. It can operate without any human intervention. Using a robotic pool cleaners are much effective in cleaning swimming pool. First is because save water and chemicals. This means you didn't need to wash your filtration system and use much fewer chemicals. Second, save time. As we know, cleaning a swimming pool is time consuming, especially a big swimming pool. So running these robotic pool cleaners can save a lot of time. Lastly is use less energy, because robotic pool cleaners use less energy than suction side pool cleaners and pressure side pool cleaners, that both of them use swimming pool's booster pump. Next is problem statement. When a swimming pool are not being cleaned for a long time, they will eventually become contaminated with germs, so it need to be cleaned regularly to prevent this. Next, as stated in my introduction, cleaning a swimming pool is time consuming and it is harder for someone who works until late night and didn't have time to clean it. Lastly is the recreational water illness. It is a disease where people can get from water they swim and play, like swimming pools, bathtub, lakes, ocean and rivers, if the water is contaminated with germs. Most common symptoms caused by recreational water illness is diarrhea, skin rash, ear pain, coughing or congestion, and eye pain. The objective of this project is to make an interesting and easy to use, controllable underwater cleaning machine that can clean dirt, debris, and clean wall and floor of the swimming pools. This robot also allows the user to learn how a robot pool cleaner works. The scopes for this project is building a robotic pool cleaners that can controlled by a controller. It must be able to clean wall and floor of a swimming pool, can collect dirt, debris and any unwanted particles and store it in its bag filter, and lastly building an easy to use transparent robot. These are the types of pool cleaners. Suction side pool cleaners pump out water of the pool inside the pool filter. So here you can see the water is pumped into the filter. After filtered, the water will return to the pool. The suction side pool cleaners will move randomly inside the swimming pool. The pressure side pool cleaners pressurize the inflow water using its second booster pump and also move in random pattern. Some debris will refloated to the surface and sucked by the pool's filter, and portion of the debris cup from the cleaners will be stored inside the bag filter. The bag filter is look like this. Then next is manual pool cleaners. It's like a suction side pool cleaners, but we need to manually move it around the swimming pool as it sucks debris into the swimming pool filters. Robotic pool cleaners has its own filter and pump system, and usually powered up by a step-down transformer. That's why it saves more energy than suction side pool cleaners and pressure side pool cleaners. Robotic pool cleaner also can move random pattern or in a programmable pattern, which is involving sensor, AI system and other stuff like that. This is my project design specifications. Weight of the robot is around 2 to 4 kg. Now, I use this robot for our old fish pond, so the length of the cable is around 3 to 5 meters. The filtration system must be a bag filter, driven by tracks, have a rotating rubber brush at the front of the robot. System is controllable robot. The dimension is 25 cm length, 20 cm width and 18 cm height. And material is a lightweight and transparent material. Next is my decision of what I use for this project. I use an acrylic sheet for material. for the body of the robot, a back filter, wired controller, DC motor for the suction motor, and an open impeller for the impeller of the suction motor. Material selected for this project is acrylic sheet because of the transparency of these plastics. The robot is made to be useful and fun to use. So when with a transparent body of a robot, user can see how the robot works. The back filter is useful because it can collect many dirt and debris and prevent clogging while on cleaning process. So the robot can run longer or at least finish the cleaning job without regularly cleaning the filter. Wired controller is chosen because it's easier to set up, and why it is controllable, not automatic, is because controlling a robot is more entertaining than just watching the robot doing its job. So basically this is how I wired my controller and DC motor using DP-DT switch. So the motor is connected to the middle section of the switch, positive to the right section and negative to the left section, together with cross wire to the bottom section. So when turn on the top switch, the motor will rotate to the right, and when turn on bottom switch, the motor will rotate to the left, depending on how I wired the motor to the switches. So for my robot, when I switch on the top section, the robot will move forward. When I switch on the bottom section, the robot will move backwards. So if I want to rotate the robot to the left, I turn on top right switches and turn on left bottom switches, so the right motor will go forward and the left motor will go backwards, resulting the robot to turn left. DC motor is selected because the speed can easily control by varying the voltage supply. This one is the circuit, example of the circuit, and this one is one of AC adapter or power supply that give multiple output power options using this tom right here. Then the rotation of the rotor can be controlled to the left or to the right by reversing the polarity of the power supply connected to DC motor, like this picture here, using DP-DT switch. The explanation also same like my controller. Track-driven robotic pool cleaners have more grip and power. As a result, they often carry scrubbers and provide deeper cleaning. Track-based models are rated to climb walls with up to 90 degrees. These pool cleaners are engineered to easily transition from pool floor to wall. An impeller is the most suitable for this project due to easy maintenance and high efficiency. It is also tested that open impeller can spin faster and have better suction process. So I would like to say that making an impeller is giving me the hardest time. This is how I make it. I draw the basic shape of the material, cut it out and shape it. First, I use acrylic sheet, but the teeth is always swaying and damaging itself. Next, I try use the plastics, but the problem here, when it rotates, the teeth expand and hit waterproof case, resulting this. Thus, I decided to use metal sheet from old power bank case. First attempt, I bent one of the teeth twice, and it break, so I made a new one. Moving on to the next slide is my rough design to help me build the robot. It has trapezium body shape. The robot is using tracks, rolling brush at the front, here over here, and the hole for water to flow out. So this is the shape, body shape of the robot. These blue parts right here represent my motor inside the waterproof case, and this part, this big one right here, is represent the back filter of the robot. This is the base of the robot. The square shape is the base of the robot. Circle Circle is the waterproof case, my motor waterproof case, and the square shape is the hole for water to flow inside the robot. Next is my demo video of my project. In this video here, you can see the rubber brush didn't rotate because the suction power is not too strong due to small impeller that I made. And here the stability of the robot is not great because of the small tracks. The tracks is smaller than the robot and making it unable to climb the wall. For future improvements, maybe I can use wireless controller with Bluetooth or Wi-Fi connections, add a small camera for the robot, make the system semi-autonomous, making the robot can be controlled or autonomous depending on the user, and lastly adding separate motor to rotate the brush for better cleaning. This project is successful in terms of usability, where it can collect dirt, debris and any unwanted particles and store it inside the bag filter, and user friendly, where I can see through the robot and easily control the robot. But the performance is not as good as real robotic pool cleaners due to the rotating rubber brush didn't rotate fast enough to clean the swimming pool. The rotating rubber brush is supposed to rotate twice the speed of the tracks or wheels. The robot also did not able to climb the wall due to the small tracks used in this project. Bigger tracks and much higher torque motor for the track might give a better results. That's all for my presentation. Thank you for watching and have a good day. Assalamualaikum warahmatullahi wabarakatuh.